All right, in this video, we're going to look at how prices affect GDP. So if you remember how we measure GDP, we take prices times quantity to get total value of production. So it's the value of all final goods and services produced in the US or in a country in a given period of time. So we take the prices times the value, or we take the quantities that we produce of each thing times the price, which is the value of that thing. And we add that all together and we multiply and then we add. So for example, if we produced vehicles and oranges, we take the quantity of oranges that we produce times the price of those oranges, and then we take the quantity of cars that we produce times the price of cars, and then we take those two values and we add them together to get total production or total value of production. And we want to look at how prices affect GDP. So let's go through an example. So in this example, we're going to have quantity in 2000 and quantity in 2007. So we have quantity in 2000 and price in 2000. And then we have quantity in 2007 and price in 2007. Okay, now for quantities in 2000, let's say we have three goods, good 1, good 2, good 3. And we produce 10, 15, and 20. So we produce 10 of good 1, 15 of good 2, and 20 of good 3. And the prices were $10 for each good. And then in 2007, we produced 10 of good 1, 15 of good 2, and 20 of good 3. And the prices were $15 for good 1, $16 for good 2, and $11 for good 3. Okay, so overall, we have prices and quantities. And what we're going to do is we're going to calculate GDP for each year, 2000 and 2007. But before we begin, I want you to take a look. If you had to tell me in which year did we produce more, what would you say? Well, if we're looking at production, we would look at quantities probably, and we say, okay, 10, 15, and 20, 10, 15, and 20. They're the same. So we were producing the exact same amount in 2000 as in 2007. So overall, if we're measuring production, production shouldn't change. So now let's calculate GDP and see what happens. So here we're going to get the value in 2000 and the value in 2007. So for good 1, we produced 10 of them. They were valued at $10 each, so we produced $100 in value of good 1. We produced 15 of good 2. We valued each of good 2 at $10, so we produced $150 of value for good 2. And then for good 3, we produced $200 of value. So GDP in 2000 was equal to 100 plus 150 plus 200. So we multiply and then we add. So 100 plus 150 is 250 plus 200 equals $450. Now we do the same thing for good 2. So we produced 10 of good 1. It was valued at $15 each in 2007, so we produced $150 of value of good 1. 15 times 15 is 225 plus 15 should be 240 of good 2. And then we have 11 times 20, so 10 times 20 is 200 plus 20 is 220 of good 3, the value of good 3. So 10 times 15 equals 150. 15 times 16 equals 240. And 20 times 11 equals 220. I think that should be correct. Let me double check my math. Okay, so we have this, and then if we add that all up, we produced 150 plus 240, which is 390, plus 220, so that's 590 plus 20 is 610. So GDP in 2007 would be measured as $610. So if we look at production, production remained the same. We produced 10, 15, and 20, and 10, 15, and 20 in each year. So overall production was constant. However, prices increased, and that's what we call inflation. Prices were going up. And if we look at what happened to our measures of GDP, we'd say we produced $450 of value in 2000, but $610 of value in 2007, even though as a country we weren't any more productive. So if we look at GDP as a measure of production, something goes wacky if prices change. And what happens is that the purchasing power of the dollar has changed. So just like your grandpa says that a dollar today isn't like what it used to be 50 years ago. So 50 years ago, a dollar could buy a lot, as compared to today, it can buy very little. So as prices increase, it says that our values increase. So we have a problem. When we measure GDP, if we include the value in that time period and the value in the next time period, GDP is going to reflect those price differences and the quantity differences. So overall, we want GDP to be adjusted so it doesn't include price changes. We want GDP to be price constant. And what we do is what we call real GDP. So we're going to measure real GDP in this case. So the GDP that we just measured is what we call nominal GDP. So nominal GDP is going to be equal to quantities in some time period. So T, if I said T is equal to 2000, it would look like quantities in 2000 times prices in that same year. So nominal GDP in year T, so nominal GDP in year 2000 is going to be equal to quantities in year 2000 times prices in year 2000. So we take quantities times prices, 10 times 10, 15 times 10, 20 times 10, and then we add them all up. Okay? So if price change but quantity remains constant, our nominal GDP is going to change with it, just like we see here. What we do in real GDP is we take a trick, and we're going to say we're going to hold prices constant. So we're not going to allow prices to adjust. So real GDP in year T, so in year 2000, is going to be equal to quantities that we produced in that year, so quantities that we produced in 2000, times prices in some base year. So we're going to pick a year and we're going to say we're going to value each good in that year only. So we go price B, where B is going to be a base year. So in this case, we could say we're going to take values in 2000. So what we valued good 1 at in 2000, good 2 in 2000, and good 3 in 2000, we're going to hold and say those are equal to the values for goods for every year. Okay? So what we're going to do is we're going to take GDP in each year is going to be equal to quantities in that year times prices in our base year. Okay? So for example, if we take real GDP in 2000, we go quantities in 2000 times prices in our base year, which we said is 2000. So we go 10 times 10 plus 15 times 10 plus 20 times 10. For year 2007, so real GDP in 2007 is going to be equal to the quantities in 2007, 10, 15, and 20, times prices in the base year, which we said is 2000. So we take 10 times 10 plus 15 times 10 plus 20 times 10. And if we do that, we get 100, 150, and 200. We add that up and we get 450. Okay? So here we'll take nominal GDP, which we insigniate $Y. So $Y in 2000 would be equal to 450 and $y in 2007 equals 610. For real GDP, which we just denote Y, so Y is GDP, so Y in 2000 is equal to quantities in 2000 times prices in the base year, which is prices in 2000. So we take 10 times 10 plus 15 times 10 plus 20 times 10. And again, that equals 450. And this is in dollars. And real GDP in 2007 then is going to be equal times quantities in 2007 times prices in the base year. So 10 times 10, 15 times 10, plus 20 times 10. And that equals 100 plus 150 plus 200, which is equal to 450. So now, if we look at real GDP as a measure of production, real GDP remain the same. And the reason that real GDP remain the same is because it's measuring quantity differences only, not price differences, because we only use prices for 1 year. So we only use this column for prices, not these two columns for prices. And these quantities didn't change, so real GDP didn't change. So if we're looking at a true measure of quantity and how productive we are as a nation, we don't want prices to influence that. We want to know how much do we produce in stuff. And to do that, we use real GDP. So we'll go through one more quick example. Actually, we'll save it for a problem set. Okay, so we'll do a problem set in another video or lecture on calculating real and nominal GDP. So with that, the next thing that we want to look at is, can we recover what happened to prices? So we know that between 2000 and 2007, prices went up. And we want to recover, can we calculate prices? Well, to do that, what happens if we have this and this. What happens if I took nominal GDP divided by real GDP? What happens? So I want to know what happens if I take $y divided by Y in a certain year. So we'll take in year T. So this might be in year 2000. Okay? Well, fundamentally what I have is I have QT times PT, that's this, divided by QT times price in the base year. And if I look at that, since I'm multiplying, I can cancel out quantities. And all that I'm left with is a ratio of prices. So if I take real GDP, or excuse me, nominal GDP divided by real GDP, that gives me a ratio of prices. So that's going to be equivalent to price in year T divided by price in the base year, or prices. Okay? So it's going to tell me how much higher or lower were prices in year T as compared to the base year. Okay? And we take this and we call this our GDP deflator. And it's a measure of prices. It's a price index. So if we take this times 100, so nominal GDP divided by real GDP times 100 is equal to the GDP deflator in year T. So let's go through. So we want to know what is the GDP deflator. We'll call it YD for GDP deflator in year 2000. Well, that's going to be equal to nominal GDP in year 2000, which is 450, divided by real GDP in 2000, which is 450, and we multiply that by 100. So 450 divided by 450 is 1 times 100 equals 100. Prices were 100% of what they were in the base year. So when we use the GDP deflator, it's what we call a price index. And an index is usually scaled as 100 in the year that we're measuring it in, the base year. Okay, so the index is it's really meaningless unless we're comparing it to some other year. So for example, if I said, oh, the Lakers scored 100 points last night. Okay, well that's great. What you really want to know is how many points did the other team score? Did the Lakers win or lose by scoring 100 points? So the Lakers scoring 100 points is meaningless unless we compare it to how much the other team scored. And the same thing happens with our index. When we look at 100, or if it says 100.7, it doesn't really tell us much, but what we want to know is how much is GDP deflator in one year as compared to the next year. If the GDP deflator goes up, prices have gone up. If the GDP deflator goes down, we can say that prices have gone down on average. So let's find our GDP deflator for 2007. So YD for 2007 equals nominal GDP in 2007, which is 610, divided by real GDP in 2007, which is 450, and we multiply that by 100. And that comes out to be 133. So what we can say is prices have gone up between 2000 and 2007 because their GDP deflator went up between 2000 and 2007. Or if you go back and look at how much prices were for each good in 2000 as compared to 2007, they were much higher in 2007. And that's what our GDP deflator is capturing. So if we want to measure quantity differences or production, we use real GDP. Quantities remain the same between 2000 and 2007. So real GDP captures that. If we want to measure what happened to prices between 2000 and 2007, we can use our GDP deflator, which measures how much prices changed. So this formula right here can be used to calculate a lot of things. So I'm going to go ahead and erase this, but just keep this formula. Okay, so we can rearrange this. So what happens if you know nominal GDP and the GDP deflator? What is real GDP in that case? So we have $y over y times 100 equals, we'll call it YD for the GDP deflator. Okay, so we have this formula. So if I know this and I know this, can I find YT? Well, I can use this equation and rearrange. So I want to solve for YT. Well, what I can do is I can multiply or divide by 100, excuse me. So that gives me YT, $YT, so nominal GDP over real GDP, equals the GDP deflator over 100. Okay, now I can multiply each side by YT, and that gets me $YT equals YT times the GDP deflator divided by 100. Now I'm going to get this 100 back over here. So I take nominal GDP times 100 equals real GDP times the GDP deflator. So notice if I have real GDP or the GDP deflator, I can find nominal GDP. Okay? So if I give you real GDP and the deflator, you can find nominal GDP. And then lastly, we can solve for YT by dividing by the GDP deflator. So the last equation, so this gives us one equation. So I can solve for the GDP deflator, I can solve for nominal GDP, or I can solve for real GDP. Going up here. So YT equals nominal GDP divided by the GDP deflator times 100. So notice how I just use the same equation to get these three different things. If I give you two, such as real GDP and nominal GDP, you can solve for the third, right? And you just rearrange this formula. So we can go through and we can recover any lost information as long as we have 2 out of the 3 variables of nominal GDP, real GDP, and the GDP deflator. Last thing that we want to cover is percentage change. And we have a percentage change formula. Percentage change in year T equals, and I'm just going to write out the formula, and then we're going to go through a few examples. So the percentage change, to find the percentage change in any variable, we take that variable in year T minus that variable in some other previous year, divided by that variable in the previous year, times 100. Okay? So for example, this is a percentage change in X in year T. Okay? And X can be used for anything. So if we want to find what is the percentage change in nominal GDP between 2000 and 2007, based on what we just found in the previous exercise. So we want to know what is the percentage change in nominal GDP. So for X, I just plug in nominal GDP. Well, that's going to be equal to nominal GDP in the later year, which was 2007, minus nominal GDP in 2000, the earlier year, divided by nominal GDP in the earlier year, 2000. And then we take that and we multiply it by 100. So now let's plug in our values. Nominal GDP in 2007 was 610. Nominal GDP in 2000 was 450. So 610 minus 450 divided by nominal GDP in 2000, which is 450. Times 100, and that equals should come out to 33%. So 610 minus 450 is 160 divided by 450 is 0.33. 0.33 times 100 is 33, and so that's a percent. So nominal GDP between 2000 and 2007 grew by 33%. So over those 7 years, nominal GDP increased by 33%. Okay? If we wanted to find the percentage change in prices, we would take our GDP deflator because GDP deflator measures prices. Okay, so this is for nominal GDP, or this is what we call growth rate. So if we're looking at percentage change in GDP, we usually call it a growth rate. How much did GDP grow? Well, nominal GDP grew by 33% between 2000 and 2007. Okay, so if we use this formula for GDP, I refer to it as percentage change in GDP or a growth rate. And we use growth rates as a percentage. Now let's find the percentage change in the GDP deflator, what we called YD. Well, that's going to be the GDP deflator in the later year, which was 2007, minus the GDP deflator in the earlier year, which in this case was 2000, divided by GDP deflator in the earlier year, 2000, times 100. So that equals 133 minus 100 divided by 100 multiplied by 100. 33 minus 100 is 100, or excuse me, 33 divided by 100 is 0.33, multiplied by 100 is 33. So this equals 33%. So again, in the previous example, we knew that nominal GDP only changed because of prices. So prices and nominal GDP grew by the same amount because quantities remained the same. So overall, prices changed or increased by 33% between 2000 and 2007 in the example that we gave. Okay. The last thing that we should notice is in the base year, if we're using base year, nominal GDP is equal to real GDP. And that's because prices in the base year are equal to current prices in that year. So in the base year, real GDP equals nominal GDP. Therefore, the GDP deflator will always equal 100 in the base year. So if I gave you a list of prices or a list of GDP deflators and I said, can you find which one is the base year? You could look through that list and say, here's where 100 is, so that must be the base year. Okay, because the GDP deflator is always going to be equal to 100 in the base year. And that's because real GDP equals nominal GDP. So the ratio is 1 times 100, it gives you 100. All right.